So in this example here, we need to begin by making an exponential model, or an equation to work with. Notice I didn't give you an equation to work with, I just gave you some basic information that you're going to have to work into an exponential equation. So I wrote down our conditions on the left. We have an initial population of 1,000 students, and we know that the population is growing 2.5% every year. I want to know when the population is going to be 1,250 students. So you're going to begin by writing an exponential equation. What's that equation going to look like? Well, I'm going to start by writing P for population. Population of students is going to be equal to. The first thing you write down is the initial condition. How many students do we start with? Well, that's easy. That's 1,000. So I'm going to write 1,000 here. Then you're going to open a set of brackets because in here you're going to have your growth rate. Well, the growth rate is 2.5% a year, but we have to change this around a little bit. So I'm going to highlight 2.5%, just with an arrow down here. First thing you have to do is express that as a decimal. 2.5% as a decimal is 0.025. Make sure you're not writing 0.25. That's a common mistake. Divide a percent by 100. That's how you get to a decimal. Because it's a growth rate, the number that we see inside the bracket in our model here must be bigger than 1. If it's not bigger than 1, then we're not going to have growth. We're going to have decay. You remember that from the beginning of this unit. So we actually have to add 1 to this number. 1 plus 0.025 is going to give us our growth factor of 1.025. And that number is going to go inside of your model, inside the bracket. So I'm going to write that here, 1.025. We're going to raise this to an exponent, and I'm going to call that exponent t for time. So look at our exponential model. 1,000 students is going to grow by a factor of 1.025 raised to the power of t. T represents the number of years that go by. So how do we solve this? I want to know when the population is going to be 1,250. The next step is to take that number and plug it in for P. So 1,250 is going to equal 1,000, bracket 1.025, all to the power of T. You need to solve for that time. That will give you when the population will reach 1,250. Well, how do we do this? The best way is to use logarithms. We could try and graph both sides of these equations, but that takes too long. Numerically, it's not going to work out very easy for us because these numbers aren't very friendly. We have a decimal here as a growth rate. So let's use our knowledge of logarithms. Step 1, let's divide both sides by 1,000. If you have that initial value out front, it's always easiest to get rid of it by dividing by 1,000. And when we do that, we end up on the left-hand side with 1.25 equals 1.025 to the power of t. Now, this should look familiar from your study of logarithms. We have a number raised to some exponent t equaling 1.25. So in other words, 1.025 raised to what power? What does t have to be in order to make that number turn into 1.25? That's how we can use logarithms to express this. Let's say that the log of our base, now in this equation, our base is 1.025. So I'm going to write that in small numbers down here. Log of base 1.025 of our big number, which is 1.25, equals t. Now remember what this means in logarithmic form. 1.25 raised to some power t will give us 1.25. We need to solve this logarithm. Let's go to a clean page, and I'm going to write that out again. Log base 1.025 and of 1.25 equals t. We can't solve logarithms if the base is not 10. So we're going to use our change of base formula, which states that we take the log of the big number using base 10, log of 1.25 divided by the log of 1.025 equals t. Now again, this is easy to solve on your calculator because we've used the change of base formula to express these logarithms in terms of base 10. So, first step, evaluate log of 1.25. It's as simple as pressing the log button, then enter 1.25, then press the equal sign. And when you do that, you should get a decimal. I'm going to show you what these numbers are so you know you're doing this right. 0.0, I'm going to truncate this to 969. Again, type in log 1.025, hit equals, and you should get approximately 0.0107 equals t. Now simply divide those two numbers, and we can round to the nearest whole number, which is 9. Now that works beautifully because we can say now that it's going to take approximately 9 years in order for that population of the school to grow to 1,250. And we can finish this off by writing a therefore statement. It will take about 9 years for the school population to reach 1,250. So write out the solution, rewatch it if you must to make sure you're catching all the steps, and when you're finished, go on and read example number 2.